Hello everyone, we are from Vellore Institute of Technology Chennai and our project is Smart AI based COVID treatment system. First, I would like to thank our faculty ma'am, Dr. Suganya ji, Associate Professor from School of Computer Science and Engineering, SCOPE, for guiding and helping us throughout our project development. And for this project, we are totally in 3 group members. Me, Uttam Keshri from final year CSE, Ashish Kumar from third year ECM and Sambhavi from third year CSE. So before starting further, first let us see with a short intro comprises what we are actually dealing with.
The coronavirus, which causes COVID-19, originated in the city of Wuhan, China. COVID-19 is believed to be transmitted primarily through inhalation. Once infected, most people experience mild symptoms, including sore throat, headache, fever, a dry cough, shortness of breath, and fatigue. However, in a subset of patients, the virus attacks the lungs, causing a much more serious infection. Small air sacs in the lungs add oxygen to your blood cells. This oxygen is then transported to organs and tissues throughout the body. When the coronavirus attaches to a cell, it begins to replicate within the cell. The body's immune system attempts to destroy the virus, which results in an inflammatory response that causes fluid accumulation in the lungs. As the lungs fill with fluid, the body's available oxygen decreases, which can lead to organ injury and death. The risk of serious complications increases if a person is elderly or has associated medical conditions. Once infected, a person may show no symptoms but can still infect others. What began in Wuhan has now spread across the globe.
These are the design modules of our project, which we will be seeing further thoroughly in detail. So this is the hierarchical task analysis diagram. In this model, we will be having a website as a portal where all the actors, patient, doctor, admin would interact. In this, the doctor and admin entry would already be added in the database, and the new doctors can only be added by the admin. Patients are provided with the sign up/login option. Now we will be having 3 dashboards for patients, doctors and admin respectively. For remote testing, we will be having under the patient dashboard, the patient can upload chest x-ray to get the predicted outcome for COVID severity, and this prediction modeling is based on the large number of pre-trained data samples using machine learning. Next, under smart monitoring system, if the user is found positive in COVID detection, then the user will be further sent for the quarantine measures, under which we have facilitated with the fever detection using the IoT device sensor programmed and module within the Arduino board. And next, the heart rate monitoring using webcam for the smart monitoring system. And the portal also have the COVID tracker system, from where an user can check the status of COVID around the nation or the globe. For medical assistance, we have built an automated healthcare AI-based chatbot. That is, the chatbot learns itself to process the input message provided by the user, and based on the corpus training, it delivers the output message for more accurately as per the human-to-human conversation. At doctor's dashboard, the doctors can view, approve or cancel the requested appointments and can prescribe the medicine as per the patient diagnosis or the health condition, and can view and reply to the patient queries. At admin dashboard, here the admin can be the receptionist, for example. So the admin can view the doctor's list and can check the list of patients, also can view the appointment details, and can also add/delete the doctors, and can view and analyze the general feedback about the COVID hospital. Also, the user can book the appointments for visiting the doctor and can check the appointment history. Also can see the list of prescriptions provided by the doctor and can ask the queries to the doctors. The COVID-19 virus detector is based on the CT scan and the chest radiography image datasets. We have used the CNN, that is convolutional neural network model, to increase the robustness of the predictions made by this model. After training the model and applying the data augmentation, the test loss and the test accuracy can be achieved more accurately. Also, I have used a linear method approach, the principal component analysis PCA, for reducing the dimensionality of a dataset. So we have done the image classification on the X-ray images in this model. We have updated the system such that it does both non-COVID-19 pneumonia detection and COVID-19 pneumonia detection using separate convolutional neural network models via two different drop list options in below. This seeks to increase the robustness of the prediction made by the system. On the task of COVID-19 detection so far, with the very limited data available, sensitivity, specificity, accuracy are 85%, 70%, 77% respectively. Where the model has been trained on COVID-19 detection dataset, which I organized for the task of non-COVID-19 pneumonia detection, the code base has sensitivity, specificity, accuracy of 89, 88, 89% respectively. The coronavirus 2019 disease is spreading rapidly with a mortality rate between 2 and 4%. By comparison, the common flu with a far lower mortality rate of 0.1% kills 2,91,000 to 6,46,000 per year. These things get worse as nCoV spreads at a triple rate at the transmission rate of the common flu, and the common flu RO is equal to 1.28 estimated transmission rate, and nCoV RO is equals 2.5 to 3.8 estimated transmission rate. So as per the current diagnosis method, we may miss the presence of the virus due to faulty DNA based comparison methods, where multiple negative test results may occur before positive results are gained. In addition, more doctors or rather more automated diagnosis method can improve identification rate of the virus. This AI driven method will reasonably help to stop the exponential growth of the nCoV strain. One more month of exponential nCoV growth is equals approximately 115 million cases, of which precisely 23 million are potential life-threatening ones, according to an epidemiologist and the PhD pathologist. As this COVID-19 is spreading rapidly, so we must have to ensure the quick and better result testing method, so the test results can be made available efficiently within the short duration of time. Till now, we have the traditional DNA testing method based on molecular serology tests, which takes around 2 to 3 days for report generation, but this AI based X-ray image scan provides the accurate result within around 6 minutes by the image processing. So the artificial intelligence diagnosis can be proved better way of testing approach for the COVID-19 virus detection.
COVID-19 shares many similarities with pneumonia. In fact, the time course evolution of a specific strain of a COVID-19 pneumonia is studied here. There are already existent pneumonia deep learning platforms, including Kaggle contents written with deep learning kernels or solutions pertaining to pneumonia detection. A pre-trained neural network is chosen from the Google pertaining to, and the pre-trained model uses is a way to avoid training on the 2 gigabytes of pneumonia or non-pneumonia training set. COVID-19 positive X-ray scans are taken from the various COVID-19 papers, such as of recent COVID-19 paper mentioned in the data section. Preliminary conclusion: this will reasonably work on potential mild COVID-19 pneumonia patients within precisely 0 to 4 days of infection, with repeated pulmonary CTs where positive findings of pneumonia associated abnormalities are discoverable. This will likely work better for patients after approximately 5 days of infection of COVID-19, as abnormalities become distributed across the lungs where initial CT scans could better discover the COVID-19 markers. Here are the list of data we have taken from the various sources, such as images from recent COVID-19 study, emerging coronavirus 2019 and COVID pneumonia, and the images from recent COVID-19 study, imaging profile of the COVID-19 infection, radiologic findings and literature review, plus 21 axial lung images, plus 11 lateral view lung images, and about plus 118 coronal view lung images, re-COVID-19 positive cases, collected by Dr. Joseph Cohen. We have taken the weights from the output section of the base 4 repository on the Kaggle based on pneumonia, and also the 2 GB training test data from Kaggle. And we have also taken the X-ray COVID-19 dataset which I have collected and organized from Dr. Cohen's collections, and these are the sources from where I have taken the files.
Here is the code setup for our COVID-19 virus detector. We have the X-ray dataset COVID-19 images for normal and pneumonia patients. These are the SARS X-ray image datasets. And these are the weights we have chosen from Dr. Joseph Cohen's. So the smart AI diagnosis tool, the user interface looks like this on the first run. From here we can choose the non-COVID-19 pneumonia images and the COVID-19 pneumonia images for COVID-19 virus detection, and subsequently we can choose the for activating the COVID-19 mode and the non-COVID-19 mode. So first I will be checking for this normal patients, and this just we have to drag and drop the images and load the image datasets. Here it says the normal lungs detected, and the value which is closer to the 0.0, which will be signifying the normalness, and the value which will be closer to the 1 signifies the illness, that means the person is having the disease or not. So let's check another one. So here it says the pneumonia detected and the value is closer to the 1. So for right now we have chosen as a pneumonia detection and the COVID-19 virus detection for normal patients and the COVID patients. So these are, so let's check for the COVID-19 mode if the person is having the symptoms of COVID-19 or not. So the normal lungs, here also says the normal lungs detected for this pneumonia patients, and we have this SARS X-ray data images which says the COVID-19 detected and the value is much closer to the 1, so it signifies the COVID-19. Also we can see this invariance record on this Python cells, and accordingly for both COVID-19 and non-COVID-19 we can see the accuracy, precision, sensitivity, specificity and the F1 score for respectively, and we have plotted the confusion matrix against that also. All the inference record are saved in this directory, can be seen here as a text format. Next, under smart monitoring system, first we have heart rate monitoring using webcam. Heart rate is one of the most important physiological parameter and a vital indicator of people's physiological state. The proposed application is a non-contact based system to measure heart rate in the real-time application using camera, and the principle is to extract the heart rate information from facial skin color variation caused by the blood circulation. This application is used for monitoring drivers' physiological state and detects the face align and get the ROI using facial landmarks. Next, it applies the band pass filter with FI 0.8Hz and FH 3H, which are 48 and 180 bpm respectively. Average color value of ROI in each frame is calculated, pushed to a data buffer which is 150 in length. FFT, the data buffer, the highest peak is the heart rate, and the amplify color to make the color variation visible. Data from a specialized device such as Compact 5 medical Econet is used for the ground truth for patient monitoring system. In certain circumstances, the heart rate values measured using the application and devices are the same. So this is the code setup for heart rate measurement using webcam. So let's run this first, the GUI Python file, that is the graphical user interface. So this is the user interface for this heart rate monitoring system. So let's start the webcam. It is detecting the blood circulation variation in the skin color and hence pixelating the image and plotting the graph against it for the heart rate measurement. So here we can see the heart rate in the BPM, and the FPS also is shown in the left hand corner, and the signal processing for the ECG for FTD and FPT are shown here. Next, in smart monitoring, we have in second the fever detection for patient monitoring. We have used an LM35 temperature sensor programmed in Python within Arduino board. As per the testing, it has been tested on Oracle VM VirtualBox. For that, we also need to be first configured by installing the server image ISO file on the VirtualBox. And as the software requirement, the Bolt IoT library using PIP has to be installed in this Python library. And the hardware requirement for this sensor device are Wi-Fi module, the 3 to male wire, and the temperature sensor, that is LM35 IoT device sensor. We have used Twilio as a third-party SMS functionality provider. It is a cloud communications platform as a service PaaS company. Twilio allows software developers to programmatically make and receive phone calls and also send and receive the text messages using its web services. So we will be having your account ID as a SID, and authorization token are highlighted, which would be later needed to be included in the Python scripts. So it would be like the temperature sensor will be sensing the temperature for patient under the surveillance, and if it processes a certain thresholds, then it would send an alert to the respective doctor handling the cases for immediate. So let's see the demo for this fever detection patient monitoring system. Next, in this project, virtual medical assistant module has been incorporated to help and assist the users based on their queries. This is an AI-based automated healthcare chatbot. This chatbot is built with the predefined library of the Python, that is Chatterbot, which is a machine learning based conversational dialogue engine built in Python and makes it possible to generate responses based on the collections of known conversations. The language's independent design of Chatterbot allows it to be trained in any language. So it trains itself with the corpus provided and perform dialogue based outcome as human type of conversation. So the SQL Alchemy is a library that facilitates the communication between Python programs and the database. Flask is a web framework. This means Flask provides you with the tools, libraries and technologies that allow you to build a web application. How it works. An untrained instance of Chatterbot starts off with no knowledge of how to communicate. Each time a user enters a statement, the library saves the text that they entered and the text that the statement was in response to. As Chatterbot receives more input, the number of responses that it can reply and the accuracy of each response in relation to the input statement increases. The program selects the closest matching response by searching for the closest matching known statement that matches the input. It then returns the most likely response to that statement based on how frequently each response is used by the people the bot communicates with. How the chatbot is trained. The chatbot comes with a data utility module that can be used to train chatbots language compatibility. At the moment, there is a training data for over a dozen languages in this module. The data which we provide for the training gets trained onto the module with the instances based on the selected language of the corpus, and thus the bot answers the user in a variability manner. This is the code setup for the chatbot. First, we need to train the bot on the corpus provided. Here we can see the chatbot is successfully being trained with all the conversations based input provided. Now we need to run the main program. Upon this successful execution of the program, the chatbot is live on the provided port. Now we need to open the browser of our choice and open the running chatbot on the live server and start the conversation. This chatbot is capable of answering all the health related queries and can also book the appointment for patients, and is very much capable for answering all the user related questions and queries. So at last we have this smart COVID hospital. This is the web application with user interface. It's designed to facilitate the users such as patients, doctors and admin. It is also fully fledged and well designed with the basic functionalities as hospital management systems, where the patients can book the appointments to the doctors and the doctors can approve the appointments or cancel it. So, and the admins can view all the list of doctors currently available. And at the last we will be having the demo from the Sambhavi, one of my team member. So let's start.
Okay, so this website right here is our basically front end part, and this has 3 modules respectively: patient, doctor and receptionist. And this one right on the screen is the registration form for the patient. If you don't have any account already, you can create it over here, and if you already have, then you can just click over here, enter your mail ID, then your password, click login, and then you will be directed to this dashboard. You can book appointment from here. General, then I'll go with the general, then Dr. Dinesh. The consultancy fees is automatically assigned. Then I'll book for the 1st November at let's say 10 a.m. Then create new entry. We are sorry to inform that the doctor is not available in this time or date. Please choose different time or date. Okay, so we'll again select general, Dinesh, consultancy fees assigned. Then okay, let's go with the 31 and 8 a.m. 8 is already done, right? 4 p.m. create new entry. Your appointment successfully booked. Okay, now you can view your appointment history. Suppose you want to cancel this one appointment, you can just click on the cancel part and it will directly cancel your appointment. Your appointment successfully cancelled. Okay, so now you can also ask question here for your kind of fever or cough and cold or whatever it is, like what to do in fever. So you can ask it over here and it would be directed to the respective doctor. Then the prescription is also there. Then by clicking on this icon, we'll go back to the home page. Let's explore the doctor part. Okay, so password, click login, and then as we can see, there are 3 functionalities for the doctor's dashboard: appointment list, the appointment cancelled by patient, and the ongoing appointment is at 4 p.m. Okay, and the doctor can prescribe right over from here. Like say the disease is viral fever, allergies just none, and prescription take rest and paracetamol. So that is it, prescribe successfully. Okay, now we'll go to the home page again. I think we missed some of the functionality. Let's explore them. Okay, so here prescription list is also there. Like just now he told take rest and paracetamol. Okay, so and regarding patient's queries, you can find it over here and the doctor can answer them. Okay, and the doctor can search the patient using his contact number. Like there are so many registered appointments. Okay, go back. Then we have the receptionist, or we can say the admin part here. If we click on login, we are directed to the admin's dashboard. You can see the password for all the doctors and the consultancy fees. Then we have the patient list and their password. Then we have the appointment details. As you can see here, 12 Sambhavi, right? Okay. Then there is a add doctor functionality. Then there is prescription list, appointment details, delete doctor, feedback and queries also is there. Okay, so let's go for the feedback part. Let's see what actually it does. Your name, let's see. Okay, nice, good job. Send feedback. Message sent successfully. Okay, so now let's see what is the receptionist actually, has the receptionist actually received the feedback or not. Once we log in, we can go to feedback or queries and it's there. Yes, nice, good job. Okay, so now we'll go to the about a section. This will show the details for this website and whatsoever services it provides. Then this is like the contact part, if you want to contact the coordinator and all. Then here we have the COVID-19 tracker. Okay, it's particularly for India basically for now. And then we have the general FAQ, question and answers. So frequently asked questions for the reference of the patient, registering patients. And this is it for now.
Thanks for watching.